People are joining. So Roderick, where are you?
Hello. Yeah, in Lexington, Kentucky.
What's that? What did you say?
Lexington, Kentucky.
Oh, cool. Thanks for joining us. Can you guys all hear me okay?
Yep. Yep.
So I'm broadcasting from San Francisco. We have my partner in crime, Proppy. I think he's in Zurich right now.
Hello.
We have another data guy, Ayin, too, from Google. Thanks for joining us. We're going to wait just another minute or two, and then we'll do a quick update on this tool called BigQuery. It's a big data analysis tool. It comes from a product we have internally called Dremel, which is what we've developed to analyze massive data sets. So think of Google's data. We've gone from when Google launched as a product, we had 26 million pages in our index. That's nothing. By 2008, we had something like 4 billion, and just a couple years ago, we had 1 trillion unique URIs in our database of pages. That's a psychotic amount of data, and that's just the index, right? Petabytes and petabytes of data in our index. We also have logs from our web crawlers and all of the internal systems as well. Think of the log traffic that our servers generate. So there's a lot going on, and we've had to develop new tools. And so BigQuery is a tool that is an external version of these log analysis tools that you can use with a RESTful API to build into your applications. So I'm going to talk about that for just a few minutes. And then we're going to talk about something really interesting, which is running pipelines and MapReduce jobs on App Engine. And we've got Proppy here, who's an expert at that. He's written some cool demos. So we're going to show you a demo or two. And we're going to talk about moving large amounts of data from Data Store, App Engine Blob Store, App Engine logs into BigQuery and Google Cloud Storage using the Pipelines API. So there's a lot to talk about. Let's see, it looks like we have a pretty good critical mass. So I'm going to share my screen and do just a really quick, hopefully not boring slideshow. And I made the fonts really big, so yeah, ping me or chat me if you can't see it. So let's get started with that. I'll show you a demo or two as well. Let's see if this thing works. All right. Can you guys all see that? Is it big enough?
Yep.
Okay, cool. So the first thing is, if you look at the link at the top of the chat, this is a link to all the documents you might need for this. There's links to some of the demos we're going to show, and some papers if you're a techie and you want to drill down, and the documents for the BigQuery API and the MapReduce library that we're going to talk about a little bit. And then there's links to Proppy and my Google Plus if you want to dig a little deeper. All right, so BigQuery. Oh, and by the way, this whole presentation is just a thinly veiled App Engine app. It's located at that URL. Let me just ping it one more time so we all have it. Yeah, there you go. Thanks, Ayin. All right, so we're going to talk about data, and we're going to talk about taking a record like this and dealing with it when it looks like this or like this. Right, we're going to talk about terabyte data sets, gigabyte data sets. So as I said before, BigQuery is an external version of the kind of log analysis tools we've developed at Google. A lot of people think that we use a MapReduce implementation to do very quick data analysis. And the answer is we found that was kind of slow. If you've ever done big data sort of SQL-style questions using something like Hive or Hadoop, it's very good and very fast, but we found that we needed to get it faster. So we developed a tool called Dremel, which allows us to use a query execution tree, a lot like MapReduce, but combined with a big cluster and a kind of column I/O format. So don't worry about the technical details. It's just we found that it's a faster way to do SQL-style analysis on massive data sets. And the best part about it is that it's an API. You interact with it via API. It's RESTful, uses JSON, and so you can use the language of your choice, and you can build these big data analysis tools with web framework of your choice. And we're going to talk about App Engine, of course, since this is the App Engine Hangout. Okay, so let me just start with a quick demo. Let me make this a little bigger. Let's see if you can see this. So this is a web UI that's based on the API. when you sign up for BigQuery, you have access to this. So let me just make it one step bigger. Okay, so we have a couple public data sets, and let me just give you an idea about what this looks like. So hopefully you can see this. I'm running a query on a data set that is the Wikipedia revision history. So this is the amount of English articles. You can see it's quite large. It's what does that say? 223 million. So there are 223 million records, right? Every time somebody revises a Wikipedia page, it leaves a revision. Make that even a little bit bigger. A revision comment. And so there are 223 million revision comments in this particular data set. There's actually more, but I'm just counting the actual articles. You know, there's discussion pages and other things. So this is a pretty meaty data set. In my opinion, from Google's perspective, it's not that big, but from your perspective, it's pretty big. And if you're using something like MySQL to do data analysis, you're going to run into limits when you hit hundreds of millions of records, right? So we're already there. Notice this query looked at 2.34 gigabytes, and it came back in 5.3 seconds. Let me just make that a little bit bigger for you. Okay, so this is the kind of query you can do on this data set. Oh, by the way, let me describe this data set for you. It looks a little bit like this, right? So it's a revision history. It has the title of an article, and it has the language and when it was updated, and there's even a comment. So that's a lot of revision. So the first thing I want to do is show you, well, what's the most revised, what are the most revised articles, right? What are the ones with the most edits? Oh, granted, this data is only up to 2010. We don't have the newest data set. I'm going to put that in there soon. So hopefully you can see this. So that was a 6-second query, right? We slammed through 9.13 gigabytes in 6 seconds, and we got George W. Bush. That's the most revised. I think a lot of you may have seen this already, but I always like running it because it's really funny. So the most revised article in our data set is George W. Bush. You know, that's not too surprising. World Wrestling Federation employees is pretty hilarious, and then Wikipedia itself, and then Michael Jackson. I think if you scroll back a little bit, you can see that like Michael Jackson beats Jesus in terms of revisions. Okay, so that gives you an idea of what BigQuery can do. The last thing I want to do is a quick drill down on vandalism. So I wanted to know why that particular George Bush article was revised so much, and I realized that in the revision history. That when a page is reverted to vandalism, that's in the comment, right? So I'm going to say this, and I'm going to say, let me just do a real quick. Let's see. And comment contains vandalism. So this is just an example of running an ad hoc query. So in 6 seconds, I got George W. Bush, Wikipedia, Star Wars, the controversial Star Wars, and controversial Neopets, right? So I guess what I'm trying to illustrate is you can quickly run ad hoc queries and on huge data sets using this tool. So let me go back to the slides and just go through. So how is it organized? Well, we have data sets which contain tables. So you have a collection of tables, and these are structured rectangular-shaped tables, right? They're rows and columns. And they have a specific schema. Right now, BigQuery supports Boolean, integer, floating point, and string. How the API works, it's asynchronous, so it's job-based. When you put in data or you run a query, you start a query job, and then you poll for the status. So first you start the job, BigQuery churns away, even though it only takes a few seconds for some of these things. Sometimes it'll take a little more depending on what you're asking. Then you poll and ask for the status. When the status is done, you make another call to grab the data, and it comes back in JSON. The libraries make this very easy. I'm just sort of describing how it works. And getting your data into BigQuery is a two-step process, and this is going to be important for the MapReduce stuff we talk about. First, you stage the CSV data in Google Cloud Storage. So you have a CSV of data, a CSV file, comma separated file, and you start an ingestion job. You tell BigQuery where the CSV data is. You say, ingest this data into BigQuery. It puts it into the form that BigQuery uses, and then you can start asking questions about your data. And the queries use a SQL-style language, as you saw, but it's not standard SQL, right? It looks like SQL because we want people to get started quickly. And it supports a lot of things that you see in SQL, aggregations like group by, string functions. We have some regex functions. And there's some capacity for joins, right? So on massive, massive data sets, it's very tricky to join. And so we added a feature where you can join a query on a huge data set with a smaller query. And I can talk about that a little later. All right, so that's all I wanted to talk about with that. Is everybody still with me? I kind of slammed through that really fast because I wanted to just give you a kind of sense of what BigQuery was all about. Now, I'll stop there and see if there's any particular questions. There's all sorts of like little idiosyncrasies that you probably are wondering about. Does anyone have any specific questions before we kind of talk about what you could actually do with BigQuery?
I have a question, if you don't mind.
Sure, Matt.
So my question, so I'm an SEO, okay?
Mm-hmm.
I'm not a developer per se of apps and things like that,
mm-hmm.
but large data sets is something that I deal with on a daily basis.
Mm-hmm.
So how do you see that I could use this type of information for me? Some parts of that gave me goosebumps because if I can pull in large data sets for certain type of keywords and things like that,
mm-hmm.
that interests me a lot.
Yeah.
That excites me, but I need to know how I could actually use this for my segment.
Right. So the thing about BigQuery is you can either create new tables anytime you want, or you can append to an existing table, right? So if you're doing something around SEO or anything, any collection of structured data, you could run a cron job and every hour ingest new data into BigQuery, and then you could have an automated process giving you updates. You could build a web app or a dashboard where you can actually check on things. We do that a lot internally at Google. We build a lot of dashboards because we're a metrics-driven company.
Yeah.
And so BigQuery is a great tool for building dashboards, right? Or if you just want to run queries on data sets and you can set up an ingestion pipeline using some of the tools that we have, you could actually just like use that web UI that I described to do some of your queries.
So is Python, could I use Python to do that with? Because right now I'm learning Python. Jonathan Simon,
mm-hmm.
who I deal with for Webmaster, told me that I needed to use Python to be able to integrate them best. That's what he told me. It's the best to use.
We support a variety of languages. I mean, I like to use Python. We have client libraries for many of the most popular languages, right? So you could even use Go if you want, Java, Python, JavaScript. We have a Ruby library. One of our people on our discussion list is writing an OCaml library. So there's lots of ways you can use it. We also have a command line tool that's written in Python that you can incorporate into your your scripts. You can use that as well. Authentication uses OAuth, but the client libraries handle that pretty well. And of course, App Engine is a great platform too, right? So if you want to build a dashboard, for example, like App Engine is awesome, and we can talk a little bit about that.
Okay.
In terms of data sizes, in terms of how big a table can be in BigQuery, we can probably handle any data size you want. I mean, I'm talking about terabytes and terabytes.
Yeah, you're gonna. Yeah, it's way bigger than what I even need, but this is what I need to start going to anyways to analyze data sets and things like that. If
you guys, so right now we're in a trusted tester period, and we're a little bit pre-launch. But if anybody on the Hangout wants to sign up for it by going to the BigQuery site, a great way to get started is to use the Python-based command line tool to just kind of get a sense of how to query data. And using that with Google Cloud Storage, you can actually you can do a lot very quickly, right? Like you just run a few commands on the command line. You can do a lot of like basic stuff through the web UI as well. So it's a good way to get started.
Okay, I'll sign up right now.
Yeah, please do. I'm basically, just so you guys know, until our trusted tester period ends, I'm pretty much letting anybody who signs up try it out now. So it's a good time to actually sign up for it. Does anyone have any basic questions before I start talking a little bit about actually moving data on App Engine?
I have a quick question, if you don't mind.
Sure, of course.
You mentioned to stage the CSV file in Google Storage. Do you support also the Blob Store, or has to be Google Storage?
So that's a good question. You can use Blob Store through App Engine, but you'll have to do a sort of a pipeline step. Mm-hmm. So we don't natively support Blob Store. We only natively support Google Cloud Storage. But I'll tell you how you can move things into Blob Store. All right. And I kind of get a sense of what you're asking. One thing is to build an automated upload system where you could actually have people upload a file into Blob Store and then automatically put it into BigQuery. Mm-hmm. I'll tell you how to build that in just a few minutes.
So we already have a process that saves the CSV file into the blob store. I just want to know how you move it through BigQuery. That's all.
Right. Okay, yeah, I'll show you that. So we don't natively support blob store as just you can't just point BigQuery to blob store. You can only point it to Google Cloud Storage. So I'll show you some methods to get it into Google Cloud Storage. It's pretty simple, actually.
Thank you.
Mm-hmm. Any other basic questions about BigQuery?
Yeah, if you don't mind.
Okay, cool. Let me show you a quick. So I'll show you an ugly demo that I made, and then we'll look at Proppy's demo. Oh yeah, go ahead.
Sorry. Quick question. Sorry, I missed the beginning. Is BigQuery also meant for live serving? I just checked on the website and it says analyze data, but is latency very low to do live serving?
Well, so it's an asynchronous API, and so yeah, I mean it's live. It's meant to use in a kind of a web application. But over a terabyte data set, it might take 20 seconds, 30 seconds to return a result, depending on what you're asking. Simple results are very fast, but like say you're doing a complicated join with a group by and then some math, that's going to take 20 seconds, 30 seconds on a very, very large data set to return a result. In that case, yeah, you can use it, but I would suggest in those cases running the queries in the background and then updating your dashboard, for example, asynchronously.
Right, and but it won't outperform a traditional data store, I guess.
Well, what do you outperform in what way?
As in, if I query over a small set, will I be faster than when I use data store?
So a very small set, data store would probably beat BigQuery, but that you would use BigQuery probably for a larger data set, right? So it's the right tool for massive data sets, whereas data store maybe isn't for when you get into the terabyte. It's a good question though. We had one of our partners did a shootout between MySQL and BigQuery, and for very, very small data sizes, MySQL will sometimes beat BigQuery. I mean, I'm talking about like sub 100 million records. But in that case, you probably don't need BigQuery. But once you get over that limit, BigQuery flattens out, right? So a query might take 10 seconds, and then you add another 100 gigabytes, and it still takes about 10 seconds, 15 seconds, whereas MySQL will take 20 minutes to return a result, right?
Right.
The 700 million plus records. So BigQuery is definitely designed for really big data sets.
Can you share the infrastructure you're running? I mean, can you tell us what internal infrastructure you're running it on?
It's based on a public paper we published last year, or actually 2 years ago. It's called Dremel, and there's a link to it on the slide. That describes almost everything about it. In fact, there's some people trying to build open versions of it. There's a couple projects that are using like Chrome V8-based JavaScript VMs to build an implementation of it. So it's something you can definitely look into and dive into. We didn't have much time to talk about it in this Hangout, but I suggest you all read it if you're interested in how we do it.
Hey Michael, I wanted to just add one thing.
Mm-hmm.
One other difference between data store and BigQuery is data store is mutable data, so you can update values, right? You can persist different values, whereas BigQuery it's sort of like append only, read only. So if you need to change values or update, you don't want to necessarily think of it as that.
Yeah, thanks, Ayin. I'm so much in BigQuery land, I sometimes forget. That's right. It's really optimized for analysis rather than transactional data. With big data, we're in this space where computers are not fast enough to do everything we want, right? So it's the right tool for the job. Some things are optimized for analysis, some things are optimized for transactional data, and we don't have one database that does everything that we want when you get into the terabyte plus data set range. So right now, BigQuery is the right tool for analysis, and it's not a tool for transactional data, but you can use it in concert with a transactional database, for example.
Yeah, I just want to react to the question that Massimo asked about do we support blob store for ingesting data into BigQuery. So as Michael said, the preferred source is Google Storage, but you can easily write an App Engine app that allow your user to upload files directly into Google Storage. So I think that Jose has made a sample of this, which is on Meetup. So maybe you can link it through the chat, and you can see how to easily do a form-based upload to Google Storage or App Engine.
Mm-hmm. Yeah, that would be great. I don't have a sample that does that yet, but I can show you a sample. First, I can show you my sample of moving data store data into BigQuery using the pipeline API, and then we can look at Proppy. He has a really great, very beautiful looking sample that moves App Engine log data into BigQuery, and we can talk about how those were built.
So Michael, you will have to demo this yourself because you are the only one who can present in the.
Okay. Okay. Cool. I'll do that. Okay. Let me show you the two demos though. I'm going to share my screen, and we can take a look at this. All right. Can you all see this? It might be too small, so let me make it a little big. Okay. So hopefully that's big enough to see, right? So this is a really simple demo of moving data store data into BigQuery. I haven't shared the source yet because I'm still hacking on it, and it's a little ugly. But it kind of shows you how this stuff works. So I'm using the MapReduce library, which I have a link to on the deck. And basically, I'm using something called the pipeline API. And the pipeline API lets you define workflows, right? So you can say, I want to run a mapper function across my data store data, and for every row, do something to it, and then dump the entire output into Google Cloud Storage. And then when that's done, I'll write another pipeline that kicks off a BigQuery ingestion job. It sounds complicated, but it's actually pretty easy, and the library makes the code very compact. So I'm going to just show you what this looks like. It has a convenient kind of control panel. So my data store data looks kind of like this. This is just a sample. It's just random stuff that I made, right? Like it's an age, it's a string, that's a description, it's a name, right? And there are no BigQuery tables. If you look here, this is my Google Cloud Storage bucket, which I'll make a little bigger. You see that there's nothing in here. There's no data in here. And I'm going to go to my BigQuery project. And there should be so there's a data store dumps data set, but there's nothing in there. So I'm going to kick off this pipeline job, and you're going to see all this stuff happen. So I click the button. Hopefully it's doing something. OK, so now it's going to launch a MapReduce job. So this is a convenient little control panel that the library provides. So hopefully it won't take too long. This is going to kick off a MapReduce job and go through the steps of MapReduce, which is break down the problem into little steps by breaking down by looking at every single data store line and doing something with it. In my case, what I'm doing is I'm appending just some extra data, but you don't have to do anything. You can just move it back and forth using the Mapper API. And Proppy can probably tell you a little bit more about that in a second. So what it's going to do is go through that. It's going to run a really simple transformation on the data, and then it's going to take all that and dump it into Google Cloud Storage. So let's refresh and see where we're at here. Looks like it's still running its little MapReduce file. Almost done. So what's great about this is the library is really easy to integrate into App Engine. And it's available on a link from that's the first page of that slide deck. It's very easy to incorporate, and we have readers and writers for data store, blob store, App Engine logs, Google Cloud Storage. So you can move data back and forth and transform it, do something with it. So a common problem we have is that, for example, you have a string and you want to turn it into an integer, or you want to do something with the string, like remove certain characters. And so what you can do is iterate through everything in the data store, and then you can do something to that every row, and then dump the result into Google Cloud Storage. Let's see if this thing is done yet. Still going. So let's see if we've gotten our Cloud Storage file. It's probably not done yet. We refresh it one more time. OK, so now we have the mapper job is done. It's iterated through everything in my data store. I think I had something like, I don't know, a few megabytes of data in there. And now it's shuffling. One thing to tell you is that this is still experimental. And if you have massive, massive amounts of data, you should definitely contact us, and we can turn on what we call Big Shuffle. In the MapReduce job, the thing that's most computationally intensive is usually what we call the shuffle sort. So MapReduce takes your job, breaks it into little pieces, does things through it across the network, and puts it all together at the end. And the putting it all together at the end is usually the kind of hard part. So let me refresh this. Hopefully it's all done. Still shuffling. Let me refresh that. Just give it one more second here.
Is the shuffler already public and the reduce?
So it's experimental. So right now, if you use the library just by default, you've got a user space shuffler. So it's shuffling basically in user space on App Engine. It's possible to use this big shuffle thing. You just have to let us know. I think there's some information about it. I just saw it this morning on the MapReduce library page. So this should hopefully be done right now. Okay, sorry this is taking so long. So let's look in this bucket and see if, oh, there we go. So now that's done. It's created a new, I don't know if you can see it, but a new Google Cloud Storage object, right? So after all that map reducing, it's taken everything in the data store and it's dumped it into Google Cloud Storage. And now let me just look one more time, and it should have kicked off a BigQuery ingestion job. Okay, now it's green, that means it's done. Let's go back to BigQuery and see if this thing is done yet. It might take another minute or so. But as you can see, this is all automated. And you know, it wasn't a huge amount of data, but it, let me refresh this one more time. Sorry, it's taking a little longer than I thought. But the point is, it's something that you can incorporate into your App Engine app. So you can collect data through Data Store or Blob Store. And there's a link, I saw the link in the chat to it. And you can actually run a MapReduce pipeline like this. And you can use this to collect data and transform data. Okay, well this part is taking longer than I thought. Let's move on to the next demo and we'll come back to it. So we want to do a log to BQ. So this is Proppy's really great demo. Oh, hopefully I can do this. So this is a really great demo. This demo moves App Engine log data into BigQuery. So App Engine log data is great. You can look at it through the admin console, but you also might want to do your own analysis on the raw data. So if I click this button, it'll kick off a similar job to what you saw, but there's a graphical interface on top of it that's really fancy, and it'll kind of let you know how fast it's going. So let's click that. So as you can see, right now we've started a pipeline to put App Engine logs into BigQuery. The first thing it does is it dumps it into Google Cloud Storage, just like you saw. Let me make this a little bigger. Hopefully you can all see that. Now it's starting the mapper pipeline. It's now dumping all of the Google Storage logs into BigQuery. And when it's done, we'll be able to run these queries live by clicking on this. So this is an ingestion job. It's still running. It takes a few seconds. While that's running, I'm going to go back to our other demo and see if this is finally done. Oh, there it is. So if you can see this, we actually have a new BigQuery table that came out of the pipeline that I ran earlier. And now, I can run queries, right? So I can say, select field and this, limit 5. And I can run a query on this data that I dumped in from Data Store. You could do the same thing. So the person who asked the question about Blob Store, you can do the same thing. Upload it into Blob Store, run a pipeline using the MapReduce library, and then dump that into BigQuery. Let's go back to this. Okay, it's done. So now I've dumped the App Engine logs from this application. I'm going to click on this, and I can run the query. I love this interface. This is awesome, Proppy. And in just a few seconds, I have a result, right? So I'm running like, what's the latency? I can run that. It takes 1.4 seconds to get the results, and I can get some latency information. Pretty cool stuff. So I'm gonna turn off the screen sharing. We can go back to ask some questions. That's right. So that was data. So we did two things: Data Store to Google Storage to BigQuery. That's right. And we did App Engine logs to Google Store to BigQuery. I went through that pretty fast. Does anyone have any specific questions about how we did that? Oh, Proppy, I can't hear you.
So there is some question on the chat.
Okay. Oh, because there's a mic problem. So the first question is, something about we're presenting Data Store to Google Storage to BigQuery. Data Store to BigQuery using Google App Engine. That's right. So that's actually there. I'll put up the code in just a few days. I need to get a code review, hopefully by Proppy, before I put it up. I've just sort of been hacking away at it, and we'll have some canonical samples you guys can use. What I guess I really should do is work on a sample that you can just drop into your existing App Engine app. I think that probably would be most useful. So imagine what you can do with this, right? Like you can collect data through the data store for your app, or maybe add it to an existing app, and then dump it into Google Cloud Storage for raw, and then you could put it into BigQuery for analysis. Oh yeah. So Jason asked a question about is it possible to remove a data set? Yeah. You can append to an existing data set. You can create new ones, or if you want to just throw them all away and ingest a whole new batch, you can do that as well. It's pretty cheap to do it all. So I guess the question is, can you add to an existing data set? Yeah. So in my demo, I just make a new data set every time, but I don't have to do that. I could actually append to an existing one. If you guys have ever used Hadoop to do your big data analysis, this is a whole different paradigm, and I think it makes you concentrate on writing your application rather than worrying about the infrastructure to handle these big data sets, and I think it's pretty cool.
I have another question.
Yeah.
You said it uses the OAuth 2.0.
Yes.
Does it use the same model that Google Storage uses? Like you can use does it use the same model, OAuth model that Google Storage uses? Like, you can authorize via a user token, or you can use the app identity or App Engine.
Exactly. In fact, both of these samples use the app identity. So yes, it is the same model for authentication.
Cool. Thank you.
There's another chat question. Is it possible to skip the Google Storage step? Well, yes and no. You can post data directly to BigQuery via a multi-part MIME post request. I find it better to use Google Cloud Storage because you're not limited by space. I think it's a little more robust. Dumping daily data store data into BigQuery is a common request, and we're looking at it. That's all I can say about that. We don't have any method to do it. Right now, the best way is to use the method I just described. Is it reasonable to append to data set hourly or even every 5 minutes? You can. Hourly is no problem. I think there's a limit to how many import jobs you can run in BigQuery, and I believe it's set to 1,000 per day. So if you're asking about real time, you're limited by that. It also takes a little bit of time to ingest. I mean, in both of our examples, our data sets are fairly small. If you get up into like the hundreds of gigabyte range, your ingestion job is going to take about 20 minutes. So that's about as close to real time as we can get right now. However, we're looking at ways to get the data in faster.
Yeah,
good question. Go ahead, Prapi.
Yeah, another advantage to use Google Storage as a middleman between the data store or any data and BigQuery is that you can easily reproduce the ingestion. So if something gets bad, you can start over directly from the Google Storage file, whereas if you do like multiple post requests and one of them is failing, you have to retry before making the other one, and it's more complicated to resume if you are doing individual post requests, whereas if you stage your data on Google Storage, you can just issue one API call to ingest the same data twice.
Mm-hmm. I totally agree with that. Well, let me answer. So Jason asked a question about pricing. So this is still a pre-release product. We're still in beta, and so I don't have any official pricing details. The only thing I can say is that when you put data into BigQuery, that costs something because it's storage. It's basically like you're storing the data in the BigQuery tables. That's probably going to be priced similar to what we charge for Google Storage, and then of course there'll be some pricing for querying. And we'll release pricing data really soon. I think we're going to be releasing it in the next week or two, so you'll know soon. Suffice it to say, I think it's a very affordable model from what I've seen. So just stay tuned. In a week or two, you'll see. Yes, this is a good question. BigQuery and Fusion Tables. I've been talking a lot to the Fusion Tables team recently, so I know a lot about this. Okay, so Fusion Tables is basically meant to be a visualization and data sharing tool. The biggest difference, well, there's lots of differences, but one of the biggest is Fusion Tables has a limited data size, right? It's excellent up until about 100 million rows, which is a lot of data. But when you really need more data than that, I know applications that collect more rows than that, in a day. So imagine if you're doing online ad serving, or you're checking. Some people on this chat were checking, URLs, and you could spider, hundreds of millions a day. So once you get to that point, Fusion Tables becomes harder to use because it just can't handle that data size. The other thing is BigQuery is essentially an API that lets you can build other apps on top of it, whereas Fusion Tables is kind of like an app with an API. So it's really an application meant for sharing and analyzing data, whereas BigQuery is really a raw data analysis tool that you can incorporate into other things. So I think one is more of an infrastructure element versus more of a visualization tool. Hopefully that answers your question, Andrew. The one thing I can say is we're looking at ways to make the connection between Fusion Tables and other Google Cloud products a little tighter, so we don't have to write a lot of code to glue it all together. Let's see. So there was a question about Python libraries. So maybe I'm not sure which page you're looking at. We have been updating our documentation pretty recently. Maybe if you can ping me the link where you say tutorials on Google developer site are presenting methods of HTTP lib. Okay, I'll check that out. I'm not sure exactly which page you're talking about, but I'll make sure our documentation is updated before our public launch. Ingestion cost. I can't tell you for sure, but likely not. So if you have to rebuild an entire data set over and over, the cost will likely be 0. Does anyone have any other questions? Cool. So yeah, this is I'm really excited about this product. I think the people are going to build really interesting things on it. We already have some people doing things with social game analytics. We have a few people analyzing weather data, which I think is really cool. I think it's also a great way to analyze things like the Wikipedia data set is fantastic, and I'm working with the teams internally to update that data so you can have the entire revision history of Wikipedia. Those are amazing things because you can see over time what articles are most updated, what articles are timely, and there's so many applications you can do with that, right? You could build dashboards, you could build entire data analysis systems on App Engine for very small infrastructure. I mean, there's no infrastructure cost, right? You're just building your app, and you can build entire businesses on data analysis very easily. Oh, Jason asked a question about trusted testers. That's right. I'll update the batch of trusted testers later today. So yeah, if anybody signs up for it, you'll get an update soon.
Yeah, I just wanted to add that with the log ingestion demo that Mayushari just showed, we are looking forward to doing something similar to AppStat that you can directly drop inside your App Engine application and get your log ingested regularly into BigQuery. So you can easily make queries on your App Engine logs, like maybe for 1 hour ago, or for yesterday, or for 1 week ago. And so I pasted the URL on the chat, so it's an open source project. If you want to take a look at it or contribute into moving into that direction, you're welcome to join the team.
Yeah, and while you're at it about app stats and analyzing data, I don't know if you guys all know Prodigal. It's a small tool I've built. Prodigal lets you doesn't do fancy analysis, but it lets you count things like latency on your app, and like that you're also able to analyze where your cost comes from and count how many signups you have. It's basically a Google Analytics for App Engine internal stuff, and it's also hooked up to app stats.
Mm-hmm. That sounds pretty cool.
Yeah, share the link, Andre. Share the link into the chat.
Oh, there it is. Cool. Yeah, I love this stuff. I can't wait to see what you guys build with this. There's all sorts of cool applications that I hope people build with BigQuery. It's really exciting. Yeah, if you guys do some interesting things, feel free to share it with us. I'd love to see what you guys are building. Yes, even commercial products. I don't care if it's commercial or not. I want to see what you guys are building. Everybody paste the links to their commercial products right now. Okay, so we're sort of winding down on our time. I probably will have to vacate the room in a second, but I just want to say, if you guys want to continue the conversation, or we went through this really fast, and there's a lot to talk about when it comes to the pipeline API, MapReduce API, what BigQuery is really well suited for. So if you have more questions, feel free to ask them on my Google Plus page, on Proppy's Google Plus page. You can reach us both there. And if you have any questions specifically about BigQuery, sign up, and then you'll get a link to sort of a more internal list. We also have a BigQuery discuss list, which let me paste the link there. That's a great one to join.
Yeah, you can also comment directly on the Hangout post that got posted to Michael profile, so we can comment in context. Like if you have specific question of about what Michael